Drew too. It's good to see you. Here to learn more math. Hey, well, our Drew is here to make your day.
I'm never going to get tired if these intros. Going to keep making them. They're going to be amazing. Today we're looking at if, only if, and only if. These questions with these kind of wordings come in a lot in university entrance papers, like this from the Tamura, can't remember what year, and this as well. And I think a lot of people look at these kind of questions who take the Tamura and just probably just guess a lot of the time, I think. Because they're not really prepared for them and they don't really understand the differences. So in this video, we're just going to go through some basic examples of using these statements in real life. Then we'll do some basic maths examples at the end. And then if you want to see these ones being done, head to the videos that have these papers, that have the full papers that I've done on Tamura, and these questions will be in there. Let's look at these three statements. I cry if I am sad, I cry only if I am sad, and I cry if and only if I'm sad. You should probably pause the video just here and just take a few minutes to think about whether or not what these statements specifically mean, and what do they not mean. A lot of the time when we talk colloquially in English, we maybe use these things interchangeably or just don't really notice the difference between these things. But the whole point of this video is that in maths talk, these things have very specific meanings, and some of them mean very specific things and don't mean other things, and likewise for other ones. So let me just break these down, because you might not really be very good at this because you haven't seen this before. But let's look at this statement. I cry if I am sad. What this means is, if you are sad, then you cry, or I, or whichever pronoun you want to use there. So the act of being sad leads to crying, is what this statement says. What it doesn't say is there aren't other situations in which I might also cry. So it doesn't say that sadness is the only thing that leads to crying. For example, you could take someone who cries 24/7 and this statement applies to them, right? If someone is just crying all of the time, on this few or many occasions in which they're sad, they will be crying, right? Because they cry all the time. So there's no exclusivity here. It's literally just saying, if sad, then crying. That's the only thing that this is saying. Okay, so I'll talk a bit more about it in the later on in the video, but when you're trying to make these into if-then statements, which is kind of how you want to write every statement you see as an if-then, this would be, if I am sad, then I am crying. That would be how you write this around. If you see if, you kind of just swap them over. It's the second one, then the first one. If I am sad, then I am crying. When we look at this statement here, I cry only if I am sad. This is slightly different, right? This is saying a slightly different thing. It's saying, if you're crying, then you are sad, because that is the only situation in which you are crying, right? It's saying you don't cry at any other time. It's only if you're sad. So if you see someone crying, that means they're sad because it's the only time they do it, right? It doesn't say, however, and this is a bit like what we saw before, it doesn't say that they cry every time they're sad. And this is a really important distinction that he's making. It's just saying the only possible circumstances in which they cry is if they're sad. It doesn't say anything about whether they cry, what proportion of the time they cry when they're sad. They might cry 1% of the time they're sad. And this statement would still be okay, as long as that was the only instance in which they ever cried, right? So there are other scenarios that could come up that leads... sorry, there aren't. That's the first one. Sadness doesn't necessarily lead to crying here, but it is the only thing that could lead to crying, is what this is saying. So again, if you want to rearrange this into an if-then statement, it's actually the first one that comes first. It's if I am crying, then I am sad, because it's the only instance in which you do that. It's not if I am sad, then I'm crying, because it doesn't say that. It doesn't say that you cry every time you're sad. It just says it's the only circumstance in which you could be crying. And I know this is very sort of finicky, but this is the exact definitions that maths goes with. So when we write the if-then statement, we swap the two things over. We don't swap the two things over. We swap them over from what they were before, right? So it's first one first this time and second one second. If I am crying, then I'm sad, if it's only if. What about I cry if and only if I am sad? It's probably not a huge surprise now. This is just a combination of the two things we've seen before, right? The first one is I cry if I'm sad. The second one is cry only if I'm sad. If it's if and only if, it's just a combination of the first two statements. So if this is true, the first two things that we read must be true. This is only true if the statement I cry if I am sad and the statement I cry only if I'm sad are both also true, right? So we need to both of these things to be true. If written as the if-then statements, like here, then remember, this one you swap them over, so sad comes first, then cry, and this one you don't swap them over, crying, then sad. And they're both true for this to be true. So what this essentially means is, like we said, a combination of both things. It means if you're sad, then you're definitely crying, and it also means if you're crying, then you're definitely sad. So it almost means these two things are now completely paired up perfectly as a nice little couple, right? One always comes along with the other, and vice versa, right? It will mean there's no other instance in which you ever cry, and it will also mean that you cry every single time you're sad. So they come as a complete perfect pair now. One never arises without the other one, and vice versa. So that's what if and only if means. It must be a combination of the top two statements. We couldn't do this again with a completely different real life example here. This is actually the example that's given in the Tamura logic notes, the big PDF file that they provide you with that is a difficult read but has some good stuff in it like these ones. So now that I've gone through these, maybe just have a read through these and make sure you understand what each mean. I'll go through them in just a second. So the church bells will ring if it's Sunday. What that means is if it's Sunday, at some point the bells will ring. Right? It doesn't say that the bells won't ring any other day. It doesn't say anything about the other days. Maybe the bells ring every single day at 12 o'clock. Maybe they ring every single hour, every single day of the week. All it's saying is if it's Sunday, they will ring. Doesn't say anything about the other days. There's no exclusivity there. It's just saying if it's Sunday. So to make it an if-then statement, if it's Sunday, I think I'll write it in later. This if-then statement will be, if it's Sunday, the church bells will ring. We swap them over if we just see an if. Now here, the church bells only ring if it's Sunday, or will only ring, or ring only if it's Sunday, however you want to word that. But the key thing is only if. Now what this is saying is, the church bells will not ring on any other day. They would only ring if it's Sunday. Will not ring on any other day. Now it doesn't say that they ring every Sunday. Maybe the only time the church bells ring is on Remembrance Sunday, once a year. That would fit this description, right? Just once a year they ring. They don't ring any other day other than Sunday, but they don't ring every Sunday. They just ring every Remembrance Sunday. Or they ring every Sunday, right? But it doesn't say they ring every day. So again, as an if-then statement, we would swap this round. And so this if-then statement would be, if it's Sunday, then the bells ring, so we swap them around. This one, we swap them around again, which means keeping them the same. If the bells ring, it is Sunday. Right. So if you want an if-then statement, I should have put a then in here, but whatever. And I also should have put a then in there, but who cares? If it's Sunday, then the bells ring. If the bells ring, then it's Sunday. So we swap them. So these two we swap over if it's just an if, and those two we keep in the same direction. Here we just need both of the previous two statements to be true. So both if-then statements are true. I know I missed the if-then here, but whatever. This would describe a church that maybe rings the bells on Sunday at midday every week, and never at any other time. So that means if it's Sunday, you will hear the bells ring, and also you will not hear the bells ring at any other day. This paired idea, right? That bells come on Sunday, Sunday mean bells, right? No other time. So we're pairing them up. Cool. So let's do a math example then. A prime number, and when we get into maths, this isn't just like a hypothetical church situation whereby the people who run the church can decide whatever rules they want. Of course, in maths has its own rules and they follow them, so you can actually decide whether these things are true or not, right? Because it's actually going to have an answer. So a number is prime if it's an integer. A number is prime only if it's an integer, and a number is prime if and only if it's an integer. Now remember, this one can only be true if both of these are. So for example, we deal with this and this turns out to be false and this turns out to be true. This one is going to be false without any more thought because it requires both of the previous things to be true itself. So okay, a number is prime if it's integer. Well, that's clearly not true because there are lots of integers that are not prime. So to make this into an if-then statement, of course, we swap the two bits over because it's an if. So it's if a number is integer, then it's prime. And that makes it very clear why this is not true. Right. There are lots of integers that are not prime, so you can't just pick an integer and say then it's prime. That's not the definition of a prime number, right? So when we write it as an if-then statement, it becomes very clear what the truth is here. And likewise here, if we write this as an if-then statement, remember, only if means we keep the two things in place. So the if-then statement goes, if a number is prime, then it's an integer. And that is actually true, right? Prime numbers are only integers. You don't get non-integer primes. So that is a true statement. Right? And it feels very wrong maybe when you read it like this, because you think, well, integers and primes, they're not the same thing. But when you write it as the if-then statement, then it becomes more clear why it's true, I think. So that's why we want to try writing things as if-then statements. And of course, this one has got to be false because it doesn't. It requires the first two statements to be both true in order for the combination to also be true. So that's definitely going to be wrong. Okay, another maths example then. Again, you can pause the video and have a go if you want to. Good, so a shape is a rectangle if it's a square. Let's just write an if-then statement. We swap the two statements over when it's an if, so we're going to say if a shape is a square, then it is a rectangle. That will be our if-then statement, but this is clearly true, right? Because if a shape is a square, it's got four sides, four right angles, two pairs of parallel sides. That's everything you need to be a rectangle, right? So if a shape is a square, then it's definitely a rectangle as well. But when we write it, when we have this one and we swap the if-then bits over, if a shape is a square, then it's a we don't swap them over, of course. If a shape is a rectangle, then it's a square. We swap them over from here. Keep getting that wrong. But anyway, we don't swap them over for any if. This is not true, right? If you just draw, when we all picture a rectangle in our heads, the shape we're picturing is not a square, right? Because we're primed to draw rectangles as like these long, thin things. So if a shape is a rectangle, then the square is false. We can all come up with a counterexample for that. And of course, the last thing is not true because it requires both things above it to be true, as we've discussed. The last thing that I want to talk about in this video is its relation to all of the other ideas that Tamura talks about. So if we take two statements, A if B, A only if B, A if and only if B. So pretend A and B are just two statements that we've seen in this video. So church bells Sunday, or square, rectangle, whatever. Any of the things that we've discussed before. If it's if, then the key rule is you write this as if this one, then this one. So you swap them over if it's just an if. Also, and you might have seen my previous video for necessary and sufficient ideas, this is exactly the same idea as that. If you see A if B, that swaps to A if B then A, and that means B is sufficient for A. So if you ever see a question that's talking about necessary and sufficient language, and you're not as comfortable with that as you are with this, then you can always just rewrite that sufficiency idea with these ideas here if you want to. It's the same thing. And Tamura doesn't use this, but these are the arrows mathematicians use. A if B means the arrow goes this way, essentially, because when you write if then, you go this way. If B, then A, following the arrow. Likewise for this one, we've discussed this means in the if then statement, you write it this one, then this one. So if A, then B, which of course means that the arrow will go from left to right. But also the word here is necessary. That means B is necessary for A, if you have it this way around. Of course, you could write this the other way around, right? Like the fact that if A then B means that A is sufficient for B in the same way that if B then A means B is sufficient for A. You could write it the other way around as well. So that's kind of interesting as well. And like I've discussed, the arrow goes the other way around. So if you're not too comfortable with this, or you're not too comfortable with necessary sufficient, but you are comfortable with the other one, then you can maybe swap them around and use whichever one you're more comfortable with. Of course, this means that you have to write it as both ways round, and they both have to be true. That means that B is necessary and sufficient for A. Of course, you just combine the two ideas. And of course, picture combining these two arrows. What would that look like? Well, it looks like an arrow that points in both directions. So that would be our kind of conclusion here and our kind of the overall ideas that we're looking at here. So if you see a statement like this, or this, or this, probably best to write it like this, and this, and this, and then it's easier to deal with. If you're more comfortable with necessary and sufficient ideas, you can deal with them instead, and you can think about it that way. The arrows are just for fun. Tamura doesn't really use them, but you will see them at university if you do maths A-level. At university. Thank you so much for watching, and I'll see you next time.